For the Lab4 patent presentation, I will be explaining defense against scan attacks. This material is taken from the patent method and system for protecting processors from unauthorized debug access. Patent number US 7334173B2. So we know that an attacker employing scan attack can retrieve the secret key inside an IC. This attack can be effectively used against any number of ICs that implements a cryptographic algorithm, like AES, DES, etc. So let's take a look at the basic scan element which is present in every IC. So a scan element is basically a flop that has an additional functionality. So if you see on the left, it is a flop that has two additional pins, a capture input and a scan in input. So on the right of this, you can see the operation. So if the capture input is high, the flop outputs the outputs the D input of the D input to the Q, and if the capture is 0, it outputs the SI input to the output. So this is a basic scan element. Now, during the IC creation process, the functional flops are all converted into scan flops, and using a method called scan chain stitching, all these flops are connected together so that the Q output are connected to the SI input, and then a complete chain is formed. A sample scan chain of length 3 is shown here. So the method of protection. So the method of protection is quite straightforward. The IC is by default disabled for scan functionality. The IC should be provided with an authentication code to enable the scan chain. And then if the authentication succeeds, then the scan chain should be functional. So implementing the scan protection. So here we are going to be providing a control scan chain, and the resulting value from this control scan chain will produce a secret key, and this secret key is used to control the other scan elements, which is part of the functional design. So to explain this in simpler terms, the IC is split into two blocks. One is the two scan chains. One is the control scan chain and the other one is the functional scan chain. The control scan chain is unprotected and it is used for authentication. The authentication created by this is used to enable the functional scan chain. We should of course modify all the scan elements in the functional scan chain to the protected scan element. The protected scan element looks as shown. So in addition to the clock, the clock is now modified by an AND gate of clock and a control signal. So the authentication scan chain, so this scan element will be the basic scan element of the functional chain shown here, and this control scan chain will still have the basic scan elements as seen in the third slide. So let's take a look at the implementation of this authentication scan chain. So here we see that, so this is a serial connection of the output of these scan elements, which is XORed with a secret key value, and after every scan stage these values are accumulated and ANDed to create the final control signal. So this control signal is what is generated at this point, and this reaches the flop that looks like this, which is present all over the all over the functional scan chain shown here. So from this diagram, it is clear that the number of possible tries to obtain the secret key value will be 2 to the power n. For instance, this 3 3 length wide 3 bit long authentication scan chain has a total possibility of 8 different secret keys. So the attacker will be forced to try these 8 different secret keys before he can enable the control signal. So this is the defense against scan chain as explained by the above patent, by the patent mentioned before. Thank you.